Hello everyone, this is Mr. Minnick, and today this is going to be the first of 3 parts of notes of information about something that in math, it's usually a pre-calculus concept, but anyway, we're going to be studying the unit circle today. And the deal with the unit circle is a lot of people are intimidated by it because what they see is this big circle. Well, it's not that big. But anyway, they see this circle. And they see all this information on it. And they say, there's no way. There is no way I can memorize that whole thing. Well, it's not so much about memorizing it as it is about figuring out why things are what they are. I've always had the philosophy that if you know why something is what it is, understanding what it is going to be easier to arrive at if you understand why it is what it is. So, the unit circle, part 1, here we go. The definition. The unit circle is a circle. Imagine that. Well, duh, oh, yeah, it's a circle. Okay, so the unit circle is a circle. What else? Well, there's more. The unit circle is a circle whose center is the origin. Is a circle whose center is, that's not 90, that's supposed to be the coordinates 0, 0. So it's a circle whose center is 0, 0, otherwise known as the origin. And the reason it's called the unit circle is because of its radius. And with radius equal to 1, hence the name, the unit circle. So the deal with the unit circle is this. A lot of times we have, somewhere here I have a picture, a 10 by 10. I think I have it in a folder over here. My everyday content. Yeah, there we go. Well, let's just put in a 5 by 5. So if we look at the Cartesian plane like so, and we were to put a circle around that Cartesian plane, let's see if I can draw a circle here. There we go. So here's a circle. Just to kind of distinguish it, let me change its color. There we go. So here's a circle. The center of the circle. Center of the circle. By definition, the center of the unit circle is at the origin. So we'd have to put the circle like that. Okay? And the deal is then the radius of this circle would have to equal 1. Okay? Radius equals 1. One thing that you need to be aware of is, and I know this might sound really trivial, but it is worth noting, a radius is a radius. And you might say, well, what the heck does that mean, a radius is a radius? You just repeated yourself. Well, yeah, I did, kind of. A radius is a radius. Well, because a radius is a radius, that's going to give us some coordinates on this unit circle that are going to be real easy to find, that are going to be real easy to calculate. And also because a radius is a radius, we're going to be dealing with some right triangles, some special right triangles. And we're going to go back to geometry for a minute and talk about some of those special right triangles and use a little bit of the Pythagorean theorem and all that. So, but first of all, the unit circle, there are angle measures, okay? All kind of angle measures. And all the angle measures on the unit circle are either 0-degree angles, 30-degree angles, 45-degree angles, 60-degree angles, or 90-degree angles. So if you understand what each one of those angle measures is, the unit circle is a piece of cake. Well, you might say, well, there's a lot more than just that. Well, there are, but they're all relatives of those. Okay? So what we'll do now on the unit circle is take a look at all the angle measures heading around the unit circle, because this is, by the end of it, remember, you're going to have to fill in the whole thing. So we'll do that in just a quick minute. So through the power of technology, we've got this ray over here, this green one. It's called an initial ray. It's a ray that kind of helps us define the measure of an angle. Okay, so we've got our initial ray, and then the terminal ray will change. Now, I don't know how much you remember from geometry when you talked about angle measures, but there's an initial ray and then a terminal ray. So if we look at this red terminal ray, as it stands, that terminal ray is coterminal with the initial ray. So the measure of this first angle over here is 0 degrees. If we were to take that red terminal ray, rotate it counterclockwise, one complete revolution. I hope that many of you remember that one complete revolution is also 360 degrees. Okay. Similarly, 2 revolutions would be 720. So 0, 360, and 720, those are called coterminal angles, meaning they share a terminal ray. Okay, so 0 and 360, so there we go. So let's go ahead and continue around here then. Remember, I said with the unit circle, everything's going to be a 0 degree angle, or a relative of it, a 30 degree angle, a 45, a 60, or a 90. If you know those, you can figure out the whole rest of it. So what do you mean by that? Well, let's look. This first stop here, remember we always go counterclockwise when we're talking about positive angles. That's 30 degrees, okay? If we go due north up here, you might realize, well, that's 90 degrees, and you're right, it is. So due north is 90 degrees, okay? Well, what bisects 90 and 0? Well, half of 90. What bisects 90 and 0? Well, that's 45. So we've got 45 degrees then. And then it was 0, 30, 45, 60, and 90. So you could probably guess that this other one here is 60 degrees. And that pretty much takes care of the whole unit circle. And you say, well, what about the rest of it? Well, the rest of it, it's going to be the same increments. It's just going up from 90, we've spun another 30 degrees. So 90 and 30 is going to give us 120 here. Then you say, well, I know 180 is a half circle, so this is 180 over here on the left, and halfway between 90 and 180, we need to add 45 to 90, so that's going to be 135. And then we're going to be 30 less than 180, so that's going to be 150. So one thing that might be helpful to remember is in between these sections here, there's 15 degree increments. There's 15 degree increments in there. Okay. Sometimes if you just happen to memorize 1 or 2, that might be handy to know. Okay. So continuing around then, after 180 we go another 30, so that's going to be 210. And then remember, 15 degree increments. So 210 plus 15 is going to be 225. 225 and another 15 is going to be 240. And then 3/4 of a revolution is 90 times 3. 9 times 3 is 27, so that's 270 down here. 30 past that's 300. And then our 15 degree increments, 315. 315 and 15 more is 330. And then we're back to the 360. So that takes care of our angle measures in degrees. That would be a good place to start when you're going to practice trying to learn and recite and fill in one of these unit circles. That's a real good place to start. All the angle measures in degrees. Okay? 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, 360. As far as a strategy goes, some people just like to go right around the clock, counterclockwise, of course. Other people like to go at different locations. I call the different locations, I call them the poles. And then I have ones I call the quarters or corners. And then the thirds, and then the sixths. And the sixths and the thirds, sometimes maybe you want to do thirds before, or the sixths before the thirds. You say, what the heck are you talking about? Well, you'll see when we get into pi radians. Okay. Um, so one more time, real quick, just to kind of recap what we just did. All the angle measures in degrees. Due east, 0 and 360. Half circle, 180. Due north, 90. 3/4 of the circle, 90 times 3. That's 270. Okay. And then going to the quarters, I got 45s, 45, 135, 225, 315. And then if I went to my thirds, then I'd be at 60 and 120. And then 240, and then 300. And then my sixth, I'd be at 30, 150, 210, and 330. Okay? So again, that's a real good starting point. By the end of today, you should be able to do that much. Some of you probably could have even done that before having seen this. Okay? So the next thing that we probably ought to talk about is pi radians. We mentioned this last week. Pi radians is 180 degrees. Okay? Now you might say, well, what's a radian? You really don't want to know. And you say, well, yeah, I do. And I'm going to say, no, you don't. The definition of a radian is so obscure, so weird, so much, it's so odd that I'm not going to include it. Okay? I will say that this is kind of like a visual representation of a radian. If I take a radius that way, a radius is a radius, and a radius that way. And if somehow I could say, well, the length of that radius, let's take that let's kind of stretch this around the circle. If I could make a arc length around that circle the same length as a radius, then whatever the measure of this central angle is, that's what a radian is. That's what a radian is. Okay? And you might say, well, how does that compare to degrees? Well, pi radians is 180 degrees. So 1 radian is whatever 180 divided by pi is. That's about 57 degrees. Okay? The big thing you need to know is this. So pi radians, some people abbreviate it with rads, is 180. Well, if you double that, you get 360. So let's see if we can apply that then to this unit circle and see what everything is all the way around then in terms of pi radians. Okay, so we lock. 0, of course, is still 0, so 0 pi. We said 360, though, is 2 pi, and 180 is pi radians. Okay? So what we're doing now is the angle measures in pi radians. And again, this is going to be part of the challenge for this week, part of what you're going to have to do on the test that you're going to take on Friday. So, what's halfway between 0 and 1? A half. But we don't write 1/2 pi. Okay, that's what it is 1/2 pi. We don't write 0.5 pi. This is varsity math. So the way we write this is pi over 2. Okay, it's the same thing as 1/2 pi. It's the same thing as 0.5 pi. But we just write it, just basically to conserve a little bit of space, we write it as pi over 2. All right? So what's halfway between 1 and 2? Well, it's 1.5 pi. Yeah, it is, but in varsity math, we don't like decimals. Well, it's 1 and 1/2 pi. Yeah, but we don't like mixed numbers either. Okay, so it's 3/2 pi. Right, but we kind of write it as 3 pi over 2. Okay, 3 pi over 2. Well, that's not so bad. Now let's go and bisect each of these. So halfway between 0 and 1/2 is a fourth. So this is going to be pi over 4. Halfway between 1/2 and 1 is 3/4. So this will be 3 pi over 4. Okay. So here's where it gets tricky. And this is where I like something I refer to as clocking. Okay. What the heck are you talking about, clocking? Well, I'll show you. So if I go this way that much, that's going 45 degrees or pi over 4. okay, every time I travel that particular distance. So there's pi over 4. If I go that much more, there's another pi over 4. Okay? If I go that much more, I've clocked another pi over 4. Okay? And you hopefully you get the idea here. So then I go another pi over 4. So let's think about this. Pi over 4, 2 pi over 4, which is really the same thing. 2 pi over 4 is the same thing as a half, right? And then I go another clock amount that much, 2 pi over 4, so 3 pi over 4, right? And then another clocking amount that much is 4 pi over 4, and of course that reduces to just pi. So if you can think that way, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, if you can think that way, you should know then, down here in the third quadrant, that 45-degree reference angle, we were 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, so you guessed it, it's 5 pi over 4. Okay. Again, clocking another 45 degrees, 5 pi over 4, so 6 pi over 4. But 6 pi over 4 is the same thing as 3 pi over 2 because it reduced. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. So then we get 7 pi over 4. Okay? So that whole idea of clocking, if you get that, it's going to be real easy then to fill in the rest. Real easy to fill in the rest. So 60 degrees. 60 degrees. We kind of saw this one, I think, in the homework the other day. 60 degrees would be, let's see, 180 divided by 3 is 60. So it's pi over 3. Pi over 3. Okay. So again, with this clocking idea, let's clock 60 degrees. That's 1 pi over 3. Let's clock another 60 degrees. If we go another 60 degrees, that's going to be, that was 1 pi over 3, so that's going to be 2 pi over 3. And let's go another 60, and that's going to be 3 pi over 3. And then another 60 is going to be 4 pi over 3. And then another 60 is going to be 5 pi over 3. Okay? So if you can think in terms of that clocking, this is going to be real easy. Finally then, moving on to the 30-degree reference angle, that's going to be pi over 3. So we got pi over 3, 2 pi over 3. Oh, no, it's not pi over 3. It's not pi over 3, it's pi over 6. Pi over 6. Pi over 6. Then we've got 2 pi over 6, which is really pi over 3. Okay, so we don't need to write that. So it's pi over 6. So let's use the idea of the complement. Halfway across would be 1 pi or 6 pi over 6, but we're going to clock backward from that. 6 pi over 6, take away 1 pi over 6 would be 5 pi over 6. 5 pi over 6 over there. Okay? Let's clock the other way. 6 pi over 6 plus pi over 6. 6 pi over 6 plus pi over 6 is going to put us at 7 pi over 6. Okay? And then finally, 2 pi would be 12 pi over 6, and we're going to be 1 less pi over 6 than that. So clocking back pi over 6 from 12 would be 11 pi over 6. Okay? Those 6 always mess people up, but if you can think in terms of fractions, if you can think in terms of clocking like that, it's really not that bad. Okay? So, to recap what we've just done, and again, if you're going to practice this, by the end of tonight, I hope that you would be able to go all the way around the circle and angle measures in degrees. In the pi radians, you should at least have the corners and the poles worked out. So we got 0 and 2 pi, pi over 2, 3 pi over 2, pi over 4, 3 pi over 4, 4 pi over 4, so 5 pi over 4, 6 pi over 4, so 7 pi over 4. And then going to the thirds, we got pi over 3, 2 pi over 3, 3 pi over 3 puts us at pi. So when we go another 60, it's 4 pi over 3. And again, another 60, that's 5 pi over 3. Okay? So that takes care of the thirds. And then finally, pi over 6. 2 pi over 6 puts us at pi over 3. 3 pi over 6. 3 pi over 6 puts us at pi over 2. 4 pi over 6 puts us at 2 pi over 3. So this is 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Okay. So that's that. So you might think, well, that's easy. I got that. Well, that's good if you think you got that. Now let's talk about the coordinates then. Coordinates. So moving around this unit circle, you might notice that on that first page, what we had are some ordered pairs, some parentheses, and some values in there. Well, those values correlate to something. In the unit circle, when you find out how it's related to everything, it's really cool. I don't know if we're going to get to that today, but when you find out how it's all related, it's really pretty cool. So, coordinates. Remember that the unit circle is a unit circle. Center is the origin, center is the origin, center is the origin, radius is 1. Center is the origin. So in terms of the Cartesian plane, the center has coordinates 0, 0. And what we like to do is put coordinates here, and here, and here, and here. We like to put coordinates all the way around. Now that's just at the four corners, okay? And that's where we're going to start. And that might be all the farther we get today. And if we do, then that's okay. The rest of the time, what we'll do is just practice, have some people come on down and randomly pick some people and have them come on down and fill some things in. So, remember the unit circle, the center is the origin and the radius is 1. A radius is a radius. In other words, no matter where you sketch that radius, the radius is always going to be 1. The radius is always going to be 1. The radius is always going to be 1. So we should be able to come up with the coordinates of that point over there, which is to the right of 0, 0. We should be able to come up with coordinates to that point very easily. It's 1 unit to the right of 0, 0. So, and it's the same height with respect to the Cartesian plane. So we have the coordinates 1, 0 right there. If we go to the left of the origin, and we go across here, we're at -1, 0. -1, 0. If we go to what I call the North Pole, from 0, 0, we went up 1 unit. From 0, 0, we didn't move horizontally, so it's 0 something, and we went up 1 unit. We went up 1 unit, so we're at 0, 1 up there. If we go to the South Pole, again, we didn't move horizontally any. We're at 0 something. We moved down 1 unit from 0, 0. We're at 0, -1. So again, for the unit circle, for what we're doing today, just to recap the coordinates there one more time. Remember, our radius is 1, the radius of the unit circle. So the coordinates are 0. Nope, not 0. The center was 0, 0. So this is 1, 0, -1, 0. 0, 1, 0, -1. Okay? So as far as what my expectation is, what you should be doing when you practice this, what you should be able to do at this point in time after watching this video is to start working degrees. 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, 360. All the degrees. Pi radians. 0, 2 pi. Pi. Pi over 2. 3 pi over 2. Pi over 4. 3 pi over 4. 5 pi over 4. 7 pi over 4. Pi over 3. 2 pi over 3. I'm going to skip 3 pi over 3 because I already got it. Another 60 is 4 pi over 3. Another 60 is 5 pi over 3. And then pi over 6. I'm going to back up from 6 pi over 6, so I got 5 pi over 6. I'm going to advance from 6 pi over 6 to 7 pi over 6. I'm going to go back from 12 pi over 6 to 11 pi over 6. And then finally my coordinates, 1, 0, negative 1, 0, 0, 1, and 0, negative 1. That's our first installment of the unit circle. It's been real, it's been fun. I hope you find this informative. If you need to watch it a couple times, watch it a couple times. Check it out, and have a great day.